I think that we're okay.
Slideshow. Okay. One slide back.
One slide back.
Yeah. We'll start again.
Okay.
If everything is okay.
I think now that's
okay. So now we'll start with the second presentation. As I said before, this presentation design study ship LNG storage and engine feeding system and concerns conversion of open type ferry to LNG fueled ship. So let's start with the introduction. The rules used, regulations used for the conversion actually is a compilation of regulations of various class societies. For example, DNVGL regulations as well as Hellenic Register of Shipping regulations were used as far as the ship operates in Greek territory. Actually, the appropriate design of the system was based also in what in regulations and standards are followed by the industry, because in some cases regulations do not exist at all. The particular ship is a Ro-Ro passenger ship, and of course the technical part of the study is one part, but also the economic side of the study is important. Actually, although the basic technical part is given here, the techno economics needs to be considered. The basic LNG storage system consists of the following components. First of all, LNG tanks, storage tanks, the piping system, evaporator unit and heating system, gas valve units, and of course the engine room machinery arrangement. So, we need to say that the design is not a single direction process. We need to close the loop and come back again to improve the design. So this is the ship, and in the table some ship particulars are shown. For example, the ship has a length of 102 meters and a breadth of 19 meters. Can carry up to 250 cars and 1,100 passengers, and the power installed power is 4.2 megawatts, and also the auxiliary power, which means the diesel generator sets. The installed diesel generator sets have a power of 415 kilowatts. And then we need to also to consider the propulsion arrangement. The ship uses, although 4 propulsion engines are installed, the ship uses 2 of these engines in each voyage leg. So it uses 2 of the Caterpillar 3512B engines, and of course the required diesel generator sets. The 2 main engines usually operate at 85% load, whereas the auxiliary engines operate at 50% load. The route duration is 90 minutes, 1.5 hours, and the duration per day is 450 minutes. So based on that, and of course also the ship stays at port for a considerable time. During this period, only the auxiliary engines operate at 85% of their MCR load. So these are the input or the assumptions used in this study, and this is how the converted or the storage and feeding system looks like. Of course, there are many options, and the first thing we need to consider is which is the option concerning the storage. So, do we use will we use typical LNG tanks of double skin, atmospheric pressure, so on and so forth, or there is another way of storing the LNG on board the ship? And in this case, based also on the port infrastructure, which of course in the specific ports there is no infrastructure at all. So in this case, and before we have the port infrastructure, then we have an issue which type of storage system installed. We decided to proceed with containerized tanks, which means that each tank has the size of a container, and it can be replaced directly without needed a bunkering procedure. So you can see the three in the case. Of course, the other option is, or the other question is about the number. So which is the number of required tanks? Because the answer comes considering the route and considering the bunkering or replacing period. And in this, for this project, we examined actually three cases: the option with 1, 2, or 3 tanks. Actually, we concluded in the solution with 2 tanks, as far as provides a compromise between the loss of payload and the bunkering time. Actually, the bunkering time required for the ship. So apart from that, a number of components are needed, which shown somewhere here. So and then the evaporator unit, the piping system, the glycol water heat exchangers, and of course the piping system, the piping feeding system of the gas going to the gas valve units, and finally provided to the engines. As I mentioned, based on a number of calculations, including the different operating scenarios, time of each voyage leg, time of staying at port, and so on and so forth, we concluded in the number of, we concluded first in the amount of LNG required for the main and auxiliary engines, and based on that, we selected the number of tanks. So tank size calculation based on one week autonomy plus 10% of tank capacity, because we need to take into account that a small amount, 10% of LNG needs to stay inside the tank to keep the temperature low. So as I said, the removable containerized LNG fuel tanks was selected, concept was selected, and then you can also see the main dimensions of a 40 feet container, so having a length around 12.2 meters, a width of 2 meters, 2.4 meters, and a height of 2.6 meters, roughly. So, and then LNG volume that can be stored is almost 32 cubic meters. So in this case, or based on that, as I say, the solution of 1, 2, or 3 tanks was investigated, and then we concluded a case. We concluded a solution of 2 tanks, and then in the second phase, after selecting the LNG tanks, the dimensions of LNG tanks, and the current amount, of course, that defines the bunkering time as well. And then we need to consider which is the best place, best location for installing of the selected LNG tanks. And then we have actually two options. The first is an open deck scenario. So the LNG tanks will be installed in the open deck, or the second option is to investigate a confined space scenario, but in both cases we need to comply with class societies regulations, and especially having in mind that storage tanks should be placed as close as possible to the center line of the ship, and minimum the lesser of B breadth fifth or 11.5 meters. And actually all of these regulations caused or resulted in the selection of the open deck for installing the tank. And I think here the slide showing the proposed location, which is actually in a platform in the open deck. So this space here is empty. So the location inside the lower garage was rejected, and then the only feasible solution seemed to be an additional platform in the one side of the ship. Ship is actually open from both sides. So on the one of the two sides of the ship, an open platform will be installed, and on this platform, 1, 2, or 3, depending on the selected option, containerized tanks can be installed, as well as the docking station with all the components, valves, equipment, piping, and so on and so forth, and of course the evaporator units. And then we need pipes, gas pipes, to feed the gas to the engines. So we can see here the location. So this is the ship. This is the location that the platform will be built, and this will be actually the base of the 2 or 3 containerized LNG tanks. And again, from another view, from a side view, we can see the platform, the proposed platform, and of course on top of this the containerized tanks will be installed. This actually seems to be the most feasible solution based on the assumptions and based actually on the schedule of the ship and the required infrastructure. Next, okay, as far as we decided about the location, about the number of the tanks, and about the amount of the stored LNG, the next question, or the next issue, next problem, technical problem, is which will be the type or the design of these or each tank. And now we have another problem, because you know that LNG stored in very low temperatures of minus 163, and that introduces loading, thermal loading, and of course contraction and expansion of the metallic structure. So a specific design of the tank was needed. In order to conclude, I think this is a preliminary design, but I need to mention that in order to conclude with a design, combined CFD and FEM analysis was used. So the tank was modeled in ANSYS, and different design options were investigated. So we concluded in the final or the best design based on the results taken from this combined CFD FEM analysis, and so finally a solution using webs fixed somewhere, I think in the middle, one point in the middle, and then leaving the tank to expand freely or to contract freely in order to reduce the stresses, was concluded. And so the next point, as far as we finalized with the design of tanks, is to examine the components. The components required for the feeding system. Now, sure that we have, we can store LNG, which means liquefied natural gas in the tanks, but we know that natural gas in gaseous form needs to be provided in the engine. So in this respect, there are various components that needs to be installed, and we need an evaporator, we need a low temperature heat exchanger, we need what else? Force valves and piping and so on and so forth. And then now there is another issue of how to design or to select the size of each one of these components, and of course the size of the piping system. This was the easy part. And then I need to remind you a little bit how the system operates, because as you can see there is no pump installed. So as far as there is no pump installed, how the pressure of the boil off gas is kept in the specified level for 5 or 6 bars, and how the pressure drop from this point from the evaporator to the engine is covered. So here, this is a nice control problem, by the way. Actually, another unit is used that you can see that takes LNG from the tank and evaporates the LNG. So the boil-off gas increases the pressure in this space here. And then, based on a second line, this boil-off gas can be heated, and the pressure here can provide the required mass flow rate in order to feed the engines with natural gas. So actually, apart from the design, other problems, control problems in a specific case exist and needs to be taken into account at least. So this shows how the LNG can be evaporated and heated. Actually, a glycol water solution will be used, 50% ethylene glycol and 50% water solution, in order to actually comply with the specifications of specific system. A very low temperature. We need anti-freezing fluids, and of course, as I explained, this is required. The glycol is required in the 2 units. First is to evaporate the LNG, and the second is to heat the boil-off gas to an ambient temperature. And then what we did is that we tried to explore a little bit on the design on the best design, on the feasible design of the heat exchanger, and in this case, a CFD analysis will be used in order to calculate the thermal, the temperature levels, and to get some insight in the operation of evaporator unit. And based on an iterative design process, we concluded on the overall dimension, as well as we actually calculated results about the operation of the heat exchangers. So that was another large task of this project. And then, so now we have the natural gas in gaseous form within the pipes, after the evaporator, and the heater. But we need to feed this natural gas in the engine room. And in this respect, some concepts, or actually two concepts, were investigated. The first concept is the protected machinery room, or emergency shutdown type protected machinery room, or the gas safe machinery room. So these are the two concepts that are used. In our case, this is the engine room of this Roro vessel, Roro ferry. As I said, two main engines in each side, fore and aft. So actually what we did, we decided to install a gas valve unit, which is a unit, as I will explain later, that controls the gas flow, the gas fed to the engines. And of course we can see also the piping system, double pipes, double walled pipes will be or need to be installed. And of course providing gas in both engines, so the gas reaches the gas valve unit and then it's distributed to the engine. One gas valve unit is needed for each engine. We have two here and two gas valve units in the aft part of the machinery room. This is how the gas valve unit looks like. So a gas valve unit is a containerized compact unit of stainless steel and includes quick closing valves, ventilation valve, filter, pressure transmitters, gas temperature transmitter, and control panel. And of course regulate the pressure to the engine and ensuring the fast reliable shutdown of the gas supply if required. So actually the control issue not mentioned or not being highlighted is also another huge design issue in this case, in case of conversion. And then double walled pipes. If you search around, if you search in the internet, you will find many types, various types of double walled pipes. I think this is the most common, with some supports between the two, the inside pipe and the outside pipe. So in this case, a double pipe of steel specified with steel A304L with vitamin insulation was selected. And of course, in this case, we have a ventilated air under pressure having a capacity of 30 air changes per hour. So all these data were concluded after studying or investigating the regulations of from classification societies, and I think this concludes of the whole design. So the platform should be installed somewhere here, and then the gas, the evaporator units will be installed on the platform, and the pipes passing through these specific routes in order to avoid collisions or problems with the car. So I think it's the safest part of the ship, and of course then going down, protected of course to the engine room. So many issues needed to be studied, including safety issues, environmental protection, performance, bunkering, convenience for passenger and crew, and so on and so forth. And that concludes my presentation. Of course, all these issues cannot be covered in one presentation. It was a whole project. I just gave you a flavor of the activities carried out in this project. So thank you very much for your attention. I'm happy to answer questions. And if you need more, I think there are some more presentation. If you Google LNG ComShip, you can find the site of the project and possibly download more presentations from there.
This project is under
This project is actually funded by a Greek-Chinese cooperation, and the Greek side is funded by the Greek Secretariat of Research, the Greek side.
now it's under which topic?
Now I think it will finish next September. So it's in an advanced level of research.
How did you treat the piping line from LNG tank to the engine? Do you treat the double wall treatment or the single wall?
I think it's double wall. Of course, this is not a final, but it's double wall just to protect the pipe in case of collision or leakage. It will be Of course, there is a work package related with safety and FSA, formal safety analysis, if I remember correct terminology, yes, it's a project that studies all the parts of conversion. Also, there is a work package in a techno-economic analysis of the conversion of the required infrastructure, port infrastructure, because we will not find developed infrastructure in ports around Europe. Only in limited cases we find ports with LNG infrastructure, possibly in Rotterdam or in Norway. So yeah, it was an interesting
Was this the machinery consider ESD or gas safe?
I think if gas safe. Yeah. Gas safe machinery. Yeah. Gas safe. So. Any other questions? Is there any question from?
Daniel, I'm checking here, but I cannot find any questions.
So this concludes this session.
Yeah.
I hope that you've got something from the two.
Any change of
actually, we found out that by using 2 tanks, the payload will be reduced only slightly. So with 3 LNG tanks, containerized LNG tanks, then there is a considerable decrease in the payload of the ship. And for this reason, we decided to go on with the 2 LNG tanks. So it depends on the number of tanks. With 1 LNG tank, there is no reduction of payload at all. Because also there are stability issues which need to be checked and which were checked. Because if you install a heavy weight, in a high, then that changes stability or affects stability of the ship. But in this case, ballast water can be used in the case with 3 tanks. And of course, if you use ballast water, then it increases the draft, and that reduces payload. So it's actually what I'm trying to say, that it's a matter of decision which needs to be taken between the ship owner and the designer. So there is no unique design, there is no, of course, there are many design options, and there are choices that have to be made.
I wonder whether this project is considered major conversion. If it is major conversion, more complicated to.
In this case, the ship was simple, so it was an open type ferry. So there were, of course, in this case, the platform needs to be added, and finite element analysis of the structure was conducted in order to calculate or to evaluate the structural elements of the platform and how these elements will be incorporated to the ship structure. Due to the size of the ship, I would say that the conversion was moderate, not huge, not small. So,
my question is because if there is a change of the capacity of passengers, this ship should be applied to the latest regulations. So in that case, this is the passenger vessel. It has to apply to the active return to port regulation. That means the machinery systems and electric systems and navigation systems to be redundant.
Certainly.
Is it considered in this project?
Yeah, as you noticed, there are 4 main engines, and actually 2 of them are used in tandem from one leg to the other. So there is redundant, certainly. So yeah, I agree with you that you need to study the conversion based on the existing rules or based on what it ensures the safety of the ship and the passengers and the crew, of course. It's important. Safety is an important issue, definitely. So if there is no any other question, we can conclude this session. Thank you very much for attending.